Okay, here we go, lesson 2. Ethan. So, yesterday we talked about the slope of a line and the fact that it tells you how steep a line is. We saw that slope can either be positive, which means the line is rising as you go left to right, or negative, which means the line is falling as you go left to right. And also, as a point of reference, if the slope is 1, that means that line makes an angle of 45 degrees with the horizontal or the x-axis. Yes? It's in that metal. What would you call that? Metal what? Mini shelf? I don't think that's a good name for it. Container. Organizer. How about that? Metal organizer. Okay. So we saw that we can find the slope of a line if it's drawn on a graph by drawing a triangle, counting the rise and the run, and then using that to get the slope. I also talked yesterday that there is a formula that we can use to find the slope. So if we look at this example here, where we want to find the slope of the line passing through 1, 5 and 3, 8. So the triangle is drawn there, and also we've written the coordinates of the bottom right-hand corner of that triangle. The x value is 3, the y value is 5. The x value is the same as the x value directly above it, because to get from this point up here down to that point, you don't go left or right. So the x values don't change. Also, to get to this point here from the 1, 5, the y values are the same, because you don't go up or down to get there. You just shift over to the right. So the height of this triangle, the rise, can be found by subtracting the y values. The 8 and the 5, the difference between those two is 3 units. That's the rise. And the run can be found by subtracting the x values. 3 take away 1 is 2. So the formula for slope is rise over run. We found the rise to be 3, the run to be 2, and it's a positive slope because the line is rising as you go left to right. So that gives us a slope of positive 3/2. The general case on the right is where you have x1, y1. So that's the x and y values at point 1. The second point, point 2, you have x2 and y2. You can find the rise by taking the difference in the y values, which in this case would be y2 minus y1. That's the rise. The run is the difference in the x values, x2 minus x1. That gives you the run. And slope is rise divided by run, which is y2 minus y1 over x2 minus x1. So this is a formula that we can use to find the slope of a line or line segment going through 2 points. And what it does is it eliminates the fact or the use of the graph. You don't have to graph it. If you have 2 points, you can just use this equation. This equation will be given to you for any quizzes or tests, so you don't have to memorize it. You just have to know how to use it. So let's look at this first example. What is the slope m of each line segment with the given points? For this first one, let's do it on the grid first, and then we'll do it using the formula. We'll see that we'll get the same answer. Doing it on the grid first, point S is at negative 3, 6. Whoops. Negative 3, 1, 2, 3, 2, 4, 6. So there's point S. The coordinates are negative 3, 6. Point T is the point 5, comma 2. 1, 2, 3, 4, 5, comma 2 is right there. That point right there. We can draw our line from these 2 points, and we want to find the slope of that line segment. This line falls as you go left to right, so that means the slope is going to be negative. And if we complete our triangle, we can count the rise and the run. So if we're going from S to T, we're going to have to rise down 1, 2, 3, 4 units. So we're going to rise -4, and we're going to run to the right. So that's a positive run of 1, 2, 3, 4, 5, 6, 7, 8 units. So this is what we did yesterday. We have our line, we drew our triangle to go from one point to the other. In this case, if I go from S to T, I'm going to rise downward, so that's a rise of -4, and run to the right, so that's a run of +8. If you went from T to S, you'd have to run to the left, which is a -8 run, but you'd rise positively, you'd rise up 4 units. Either way, one of them is negative, which will give you a negative slope. So for part A, M, the slope is rise over run. Again, this is the formula that we're always going to be using. This statement. The way I did it, it was a rise of -4 over a run of +8. And because 4 and 8 are both divisible by 4, we can do that to simplify this, -1/2. There's the slope of that line using the graph. However, we can also do it by using that slope formula. y2 minus y1 over x2 minus x1. If we use the formula, we don't have to draw the graph. All we have to do is say, okay, if S is our first point, we can say that those are the values of x1 and y1. That would make T our second point. So that would be x2 and y2. So again, you have to designate one of the points as being point 1, the other as point 2. And it doesn't matter which way you do it. I could have let T be point 1 and S be point 2. It doesn't matter. You'll get the same answer in the end if you do it correctly. But I just said because S was given first, that's point 1. So the -3 is the x value at point 1. The 6 is the y value at point 1. If T is point 2, the 5 is the x value at point 2. The 2 is the y value at point 2. So y2 is +2 minus y1, which is +6, over x2, which is 5, minus x1, which is -3. So again, you see what I've done here. If I said that S is point 1, that gives me my values of x1 and y1. That makes T point 2. That gives me the values of x2 and y2. The slope formula says I'll take y2, take away y1 on the top. y2 is 2 minus y1, which is 6, over x2 minus x1. x2 is 5, take away x1, which is -3. 2 minus 6 is -4, and when you have 5 take away -3, the minus becomes a plus positive. It becomes 5 plus 3, which is 8. So you see you get the same thing as above, -4 over 8, which is -1/2. No matter which way you do it, you get the same answer. But by using the formula, you don't have to draw the graph. So that's how you use the slope formula. So let's use the slope formula to finish off the rest of these. B says I'm going to go through H, which is 4, 3, and K, which is 4, 8. Let me just move this or copy it. Copy it below here. Okay, so for this one here, if I say that H is 0.1 and K is 0.2, and again, I could have reversed these. I could say that K is 0.1 and H is 0.2. It doesn't matter. But because I've designated H as 0.1, that gives me my values for x1 and y1. K is 0.2, that gives me my values for x2 and y2. The slope formula says that m, the slope, is y2 minus y1 over x2 minus x1. By using this formula, we don't have to draw the graph. So y2 is the y value at 0.2, which is 8, minus y1, the y value at 0.1 is 3. On the bottom, x2, the x value at 0.2 is 4, minus x1, the x value at 0.1 is also 4. So the top, 8 take away 3 is 5, over the bottom, 4 minus 4 is 0. If you're trying to go 5 divided by 0 on your calculator, you're going to get an error, because you cannot divide by 0. It's undefined. The slope doesn't exist. And so we can use the infinity symbol for that. And the reason for that is this line is vertical. The x values are the same. They're both positive 4. What's different is the y values. The y value at k is 8. The y value at h is 3. K is directly above h. It makes a vertical line straight up and down. And we saw yesterday that when that happens, the slope is undefined. It doesn't exist. And the slope formula tells us that. Right? So that was B. So let's do C. So again, by using the slope formula, we no longer have to graph it. So for C, I've got M and N. If I say that M is 0.1 and N is 0.2, I could have done it the other way around. It doesn't matter. You'll get the same answer in the end if you do things correctly. But I just said the first point is 0.1, so that gives me my values of x1 and y1. The second point is 0.2, so that gives me my x2 and y2. And the slope formula says that m, the slope, is y2 minus y1 over x2 minus x1. Again, that formula will be given to you, so you don't have to memorize it. You just got to know how and when to use it. So based on the fact that m is 0.1 and n is 0.2, the formula says y2 minus y1 on the top. y2 is negative 7 minus y1, which is also negative 7, but I'm subtracting them. It's negative 7 minus negative 7. Over x2 minus x1, negative 1, take away negative 9. Remember that a minus minus becomes a plus positive, so negative 7 plus 7 is actually 0. And you can put this in your calculator exactly the way it's written. Negative 7 minus negative 7. It'll give it to you. That's 0. Over negative 1, again the minus minus becomes a plus positive. Negative 1 plus 9 is positive 8. And 0 divided by anything is 0. You see, this line is perfectly flat because their 2 points have the same y values. They're both at a height of negative 7. This is a horizontal line, and a horizontal line has a slope of 0. So that's the slope of that line. Okay, what about question D? So we'll do E, and then we'll do F. Or I should say we'll do D, and then we'll do E. Whoa, where did I go? There we go. Try this again. Okay, here we go. So if I want to find the slope of the line going through A and B, I can let A be 0.1 and B be 0.2. I can switch those around, it doesn't matter. But because I let A be 0.1, now I have to say that these are the values of x1 and y1. B is 0.2, so those are the values of x2 and y2. And again, the slope formula, y2 minus y1 over x2 minus x1. y2 is negative 5 minus y1, which is negative 2, over x2, which is 3, minus x1, which is 0. Again, a minus minus becomes a plus positive. Negative 5 minus negative 2 becomes negative 5 plus 2, which is negative 3. And again, you can do that on your calculator exactly the way it's written, and it'll give you the right answer. Negative 5 take away negative 2 is negative 3. On the bottom, 3 take away 0 is positive 3. And negative 3 divided by positive 3 is negative 1. That's the slope of that line. So that tells us two things. The line is falling as you go left to right because it's a negative slope. And because the slope is 1, that means that that line makes an angle of 45 degrees with the x-axis. But it falls as you go left to right. Okay, try question E on your own using the slope formula. Try E on your own and then we'll check it. You have an answer, Ethan? Pardon? So if you let C be 0.1 and D be 0.2, like I've written there, then at 0.1 C you've got x1 and y1. At D you've got x2 and y2. The slope formula, which will be given to you, is that m, the slope, is y2 minus y1 over x2 minus x1. Y2 is 3 minus y1, which is negative 2, over x2, which is 4, minus x1, which is also negative 2. In both cases, the minus minus becomes a plus positive. 3 plus 2 is 5 over 4 plus 2, which is 6. This line has a positive slope, meaning it's rising as you go left to right. And 5 over 6 is a decimal that's just a little bit less than 1. So that line will make an angle a little bit less than 45 degrees to the x-axis. Okay, so that's what you should have got. Did anyone do it the other way, letting C be 0.2 and D be 0.1 and not get the right answer? Because you'll get the right answer if you do it correctly. No? Everyone's good? Okay. Example 2, Matt's backyard has been flooding, so he decides to install a drainage pipe. He learns that the pipe needs to drop 1/4 inch per 1 foot length. What does it mean that the pipe drops 1/4 inch per 1 foot length? So what that would mean then is that the pipe would have to have a negative slope because it's dropping. That's what this means. The pipe has a negative slope. That's what it means. Now, to find the slope of the pipe, remember that slope is rise over run. And when you do this, they have to be in the same units. And right now, they're not in the same units because the drop, which will be the rise of negative 1/4 of an inch, is in inches, where the run, which would be the length part, is in feet, 1 foot. So to do this properly, you have to convert them both into the same units. So we can say that the rise for now is negative 1/4 inches, but the run is in feet, 1 foot. In order to calculate the slope as a number, we have to have these in the same units. So what we would probably do is convert the foot into inches. 1 foot is 12 inches. And so now we can calculate our slope. In brackets, I'm going to go negative 1 over 4. So that's my negative 1/4 for the rise, divided by 12 for the run. And so there's my slope as a decimal. It's a repeating decimal, negative 0.02083 repeating. Negative 0.02083 repeating. That's the slope of that pipe. And so because the 3 is repeating, we put a little line over the top of it. That tells us that that number is repeating. If the horizontal run is 100 feet, how much lower should one end of the pipe be than the other? So in other words, this is asking us what the rise will be. Okay, we already have calculated the slope. Remember that slope equals rise over run. In this case, our slope is negative 0.02083 repeating. And we want to know what x the rise in if the run is 100 feet. So we did questions like this yesterday where we were given the slope and we were given either the rise or the run. We wanted to find the one that was missing. And we often did that by making sure that both sides were fractions. So I can make the left side a fraction by putting it over 1, and then we cross multiply. You got your booklet from yesterday? Okay, you can grab one from the metal organizer on the bottom rung there. There's a booklet. And do you have a pencil? I'm sorry? Grab one off my desk if you need one. Just make sure you put it back, okay? So like we did yesterday, we can cross multiply. The 1 times the x is x, and that will equal negative 0.02083 repeating times 100. And that decimal is already in our calculator. So we can just go times 100. And we'll get negative 2.083 repeating. Let me just move this over here. There we go. Negative 2.083 repeating. So this is the rise. Let's put that in brackets. The negative part means that it's going to be below the other end where the pipe starts. Okay? So that means it's going to be 2 feet below plus 0.083 feet more. All right? So the question says answer in feet in inches, because right now this is just feet. The negative tells us that the other end is below the starting end. It's 2 feet below plus 0.083 more feet below. So we've got 2 feet. We need to know how many inches this 0.083 of a feet is. So if I look at the decimal I have on my calculator, if I want to just get the 0.083 repeating and not the negative 2 in front, I could do this a couple different ways. One of them would just be by adding 2. That will cancel with the negative 2. Or the other thing I could have done is divide by negative 1, because that would have got rid of the negative sign as well. But I'll do that now. I'll divide by negative 1 to get rid of the negative sign completely, so I just have that decimal. This represents a portion of feet. To convert that to inches, remember there are 12 inches in a foot, so I'll multiply by 12, which will be 1 inch. So 2 feet 1 inch below is our answer. That's how much lower the one end of the pipe will be compared to the other. All right, example 3 says a 60-inch TV. So notice where the 60 is drawn. When you look at an ad or you're in a store looking at TVs and they give you the size of the TV, they're giving you the length of the diagonal. And the reason they do that is because that will always be the largest number. Okay? You can see that the width of this TV is only 52 inches. The height looks like it's a little bit less. It'll be something less than 52. The diagonal is always the longer side between the width and the height, always. It's a bigger number. So it's kind of false advertising. When you look at the size of a TV in inches, it's always the diagonal, which is the biggest number. So again, it's a little bit of false advertising. But anyways, it says you got your 60-inch TV. What is the slope of the diagonal? So we need to know the rise and the run. The run is 52. We're not given the rise, but we can calculate the rise. And here's how. If we draw a triangle here between the base, the height, and the diagonal, that triangle will be a right triangle. And I got my lines off here a little bit. I just have to move this up so that it's only on the screen part. That's better. So the base of the triangle would be 52 inches. We need to know what h the height is. But these three sides that I've drawn in yellow form a right triangle, which means we can use Pythagorean theorem. Okay, we've seen this before. Pythagorean theorem says that a squared plus b squared equals c squared, where a and b are the two legs of the triangle. The hypotenuse, the longest side, is always c. So if I say that a is the height, b is the width, which is 52, which needs to be squared, and that must equal c, which is 60, which is also squared. I'm going to calculate what h is, and then I can find the slope. That represents the rise of the TV screen. So you can use your calculator to find out what 52 squared is. That's 2704. And you can also find out what 60 squared is. I think that's 3600. Yep. And we need to calculate what the value of h is. Before we can get h, we have to get h squared by itself by subtracting the 2704 from both sides. We need to get the h squared by itself. So on the left side, the 2704's cancel. When you subtract 2704 from 2704, they cancel. And on the right side, you've got 3600 minus the 2704. That is 896. That's what h squared is. Then to find out what h is, we take the square root of both sides. The square root of h squared is just h. Square root and square are opposite operations, so they cancel each other out. And on the right side, I have to take the square root of 896, which is 29.93 approximately. And that represents the rise. So the slope, m, which is rise over run, will be the 29.93, that's our rise, over the run, which is 52. It does say to write it as a decimal to the nearest tenth. So I'm keeping that entire decimal in my calculator. I need to divide it by 52. And to the nearest tenth, it would be 0.6. That's the slope. It's positive because you can see that that yellow line that we drew, that 60-inch line, is rising as you go left to right. So that is a positive slope. Positive 0.6 approximately, because we rounded it. Okay, so again, in this case, we had to calculate the rise, and we did it using Pythagorean theorem. So you're probably going to see questions like that on your assignment. This next one says, complete the table below express each slope as a simplified fraction. Remember that slope is always rise over run. The one thing you want to make sure, though, is that the rise and run are in the same units. And for the first three, they are. For the first one, the rise is in meters, the run is in meters. So, remembering that slope is always rise over run, it'll be 25 meters divided by 75 meters. The meters cancel, and you'll have 25 over 75, which you can reduce that fraction by dividing top and bottom by 25, and you'll get 1 over 3. That's the slope of that line. Some calculators have a fraction button on them. If you go 25 divided by 75, you'll get the decimal. And on my calculator, if I hit the math key here, the very first choice in the math tab is to go to a fraction. It takes the previous answer and turns it to a fraction, 1 over 3. So some calculators have that ability to convert from a decimal to a fraction. Ethan, bring your phone up here. Bring your phone up here. Yeah. No, you weren't. You definitely were not. Up here. You're not supposed to have your earbuds in either, right? This is for your own good. You'll find it easier to pay attention if you're not distracted. So question 2, again, they're both in inches. So we don't have to do any conversions. We can just go rise over run. 12 inches over 60 inches. The inches cancel. So it's just 12 over 60. And those are both divisible by 12. You can divide top and bottom by 12, and I think you'll get 1 over 5. But we'll check that on the calculator. Because when you write it as a decimal, some calculators will convert to a fraction, and it is 1 over 5. Question, or the third one, they're both in centimeters, so we don't have to do any conversions. It'll just be rise divided by run. And 45 divided by 15 is exactly 3. That's the slope of that line. All three of these have a positive slope, so as you go left to right, the line is rising. Now for the next one, they're not in the same unit. The rise is in feet, the run is in inches. We have to have them in the same unit, so remember that 1 foot is 12 inches. You have to do that conversion before you calculate the slope, which will be a rise of 12 inches over a run of 18 inches. 12 divided by 18 is 0.6 repeating, yeah? Okay, thank you. There we go, thanks. And if you can write that as a fraction on your calculator, it's 2 over 3, because if you take the original fraction and you divide top and bottom both by 6, you'll get 2 over 3. And the last one, again, they're not in the same unit. The rise is in meters, but the run is in centimeters. So you're going to have to convert, and 1 meter is 100 centimeters. So we'll have a rise of 100 centimeters divided by a run of 250 centimeters. If you do that on your calculator, it gives you that decimal 0.4, which as a fraction is 2 over 5. You see, if you take the original fraction and divide them both by 50, you're going to get 2 over 5. Okay? Example 5 says that a farmer or a section of a farmer's land is shown in the diagram. Determine the slope of this part of the land. Well, again, it's always the rise over the run. But notice that the run is in kilometers where the rise is in meters. We have to have them in the same unit. And because there are 1,000 meters in a kilometer, if we take the 5 kilometers and multiply by 1,000, we're going to get 5,000 meters. So m, the slope, which is the rise over the run, will be 20 meters over 5,000 meters. There's some other measurements that are given there, but we don't need them. All we need is the rise and the run. Now, if we look at this, you can divide top and bottom by 10, which will take care of one of the zeros on the top and bottom. If you divide top and bottom by 10, that'll take care of one of the zeros on the top and the bottom. And then you can divide by 2 and get 1 over 250. There's the final answer. Now again, if you use your calculator and go 20 over 5,000, it'll give it to you as a decimal. And if you have the ability on your calculator to change it from a decimal to a fraction, you get the same answer, 1 over 250. Example 6 says the slope of the hill in the picture is 5 to 2. The horizontal distance to run is 42 meters. Determine the vertical distance to rise. So this slope is given to us as a ratio instead of a fraction. But all it means is that the first number is 5, the second number is 2. The top number is 5, the bottom number is 2. So m, the slope, which is, again, rise over run, m is 5 over 2. It's just given as a ratio instead of a fraction, but we can convert it. 5 is the first number, so that goes on top. 2 is the second number, that goes on the bottom. We want to determine the vertical distance, the rise, if the run is 42 meters. So we've done questions like this before. Whenever two ratios or fractions are equal to each other, their cross products are equal. So 2 times x equals 5 times 42 meters. And so now we'll use our calculator. On the right side, 5 times 42 is 210. 2x equals 210 meters. And then you divide both sides by 2 to get the x by itself. The 2 and the x are hooked together by multiplication, so we do the opposite, which is divide both sides by 2. So on the left, 2 divided by 2 is 1. You'll get 1x, or just x equaling, and 210 divided by 2 is 105 meters. And so there's our answer. That is the rise of that piece of land. 105 meters it rises. Okay?